Okay. So in a second, we're going to watch this video. But first, what I want to talk to y'all about what you have in front of you. So did you already pass yours back? What do you have back there in the on the actual bag? What chemical does it say you have? You got two of them, but what do you got? Not you. Am I looking at you and pointing at you? No. Well, this is basic kind of stuff. So if I'm not looking at you and pointing towards you, and I'm looking at someone else and pointing at them, hold your comments until we're done. Okay?
I was looking down.
Yeah. Well, maybe look up. I wasn't like generally broadcasting to the whole classroom. What do you got in your bags? What's the S? Sulfur. And then what's the other one? What is that, like the pellet one? Okay, so what can, let me see what's it say on there. Oh, PB. PB is going to be lead. So he's got sulfur and lead. On the lead package, what number do they give you?
207.2.
207.2. On your periodic tables, what is the very bottom number in the box for lead, PB?
106.42.
No, is that true?
Yeah.
You looked at the wrong thing.
No, he's not.
Yeah, lead, PB, what's the bottom number in that block?
PD.
No, PB, PB, 207.2, lead. I also said the name of the element if you got the letters wrong. The name is lead. What is PD?
Palladium.
Palladium, completely different metal, not lead. So lead, make sure you have the right name and the right formula, but lead has the number 207.2. So back here, what he has in his bag, hold up the lead bag, or somebody else already has. Hold up the lead bag. What you have is little lead pellets. I don't know where they came from, but little lead pellets. And how much does that bag weigh? What's it say on the front? 207.2 grams. And what else does it say on the front there? What other number do they have? Don't pass it off to somebody. What other number does it say on the front there? What other number does it say on the front? Besides the 207, what does it tell you? 1 mole. So 1 mole of lead, 1 mole is equal to the number they have here on the periodic table. Same thing with sulfur. What's the number, again, what's the number you have next to the sulfur there in grams? 32.06. So I look on the periodic table, and 1 mole of sulfur weighs 32.06 grams. So every single bag that I have going around the classroom is exactly 1 mole of that chemical. Aluminum up front here, this is like an aluminum powder, 26 grams. Iron right there, just like an iron powder. How many grams there?
55.85.
55. If we look for iron on the periodic table, that number at the very bottom of that square is 55.85. If we find aluminum on the periodic table, the number on the bottom of that square is 26.98. So just using the periodic table, we can always find out exactly how much weight 1 mole of that chemical will give us. Who's the one that has the water? You got the water back there? What's the number that they have for water? 18.02. But here's where we get to a little bit of math. And we're going to end up doing this on a different assignment, or maybe on this one, we'll see. What's the formula for water? H2O, right? And so we actually have, that was a terrible H. Hold on, let me redraw this. We know the chemical formula for water right off the top of our heads, and we can add up 2 hydrogens and 1 oxygen. How much does a hydrogen weigh? 1. Don't round off my numbers now. 1.008. 1.008. How many of them do I have? 2. So I have 1.008, 1.008. How much does water weigh?
15.999.
15.999. And then if I add these together, who's got the calculator? So I don't have to do my math. I mean, we know it's going to be really close to something, but let's see. 17, it's going to be 18 point.
0.015.
0.15. Yeah.
It's 1.8087 times 10 to the 1.
No, it's okay. It's close though. So 18.015 is our weight. If just from using the periodic table, 2 hydrogens and 1 oxygen. Is that what they say on your bag, or are they close to that? Yeah. And so not having really any information at all. If I know the formula and I have my periodic table, I can find out how much 1 mole of that chemical weighs just by adding it up. Or if it's just one element like aluminum or iron or sulfur, I just look up that one element from the periodic table. I don't even have to add. But what does a mole mean? Does anybody remember the number for a mole from back before spring break? Not spring break, sorry, Christmas
You
break.
silly.
The important part of the question was the number for a mole. Does anybody remember the number for a mole? Does anybody remember what it started with?
Not
2.
I know like 90% of y'all did these assignments, so maybe it's a good thing I'm reteaching.
I did it, but I guess.
Well, you're not guessing on this. It's either the number or it's not the number. You're not going to guess this number.
2.008.
No.
No, I know like 2 million.
It's a lot bigger than 2 million, but you're getting closer because you're getting much, much bigger.
6.82.
Here we go. Someone remembered something. What do we got?
6 billion.
Well, don't worry about the size yet, but what are just the numbers?
6.8.
No.
08.
8.
You said it earlier. Stop being dumb. 6.02. And then I made a mistake. I always battle with sapling over this because the number that they give you most of the time is 6.022. Sapling really only gives you the 6.02. They round this off. I tend not to round this off, but I'm going to stop doing this year and just give you this number. But here's why. Let me show you why. Does anybody remember the exponent that we used at the end here?
-34.
Oh my gosh.
Well, actually, no, wait.
What do you?
It wasn't negative 34.
It's
It's-
34.
I think it's positive 34.
Yeah.
But y'all are just yelling stuff out, and now you're like confusing me a little bit. I'm pretty sure it's times 10 to the 34th power. No. Is it 23rd power?
Yeah, I think it's
Yeah, it's 23rd. See, y'all just screwing me up.
No.
Just yelling stuff out.
I think
that's
it's 70.
20. Yeah. Planck's uses 34. Thank you. My bad. So it's 6.02 times 10 to the 23rd power. And if you write this out, here's why I never really rounded that off. Because in this number, does that 2 look like it's very big? No. But when I write this out with the times 10 to the 23rd, what this becomes is 6, 0, 2, and I'll put a 2 here, like I'm using this number times 10 to the 23rd. And then I have to have what? 20 more zeros. 1, 2, 3. So 20 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. I believe that's right. Comma here, comma there, comma there. We're getting kind of big here. Yes. So this is what? Thousands. This is millions. This is billions. What comes after billions?
Quadrillion.
Quintillion?
No.
Trillion?
Y'all are gonna be poor. Come on.
Tetrillion.
After billions, you get to trillions. No one's gonna invite you to the country club if you don't know what comes after billions. You gotta get the big money talk. Trillions comes after billions.
Quadrillion.
Yes, quadrillions or quatrillions after trillions. This is where you're getting super rich. And you can start to buy continents instead of islands. Yeah, after quat would be pentillions, I guess. And then at the end,
I
sextillions.
know my stuff.
And so this is 602 sextillion. But look, if I round this 2 off like sapling does, which is fine, we're going to use this bottom number because that's what sapling does. But if I round this 2 off, what am I really rounding off? I'm rounding off 200 pentillion whatever. If they were dollars, would you just throw away 200 pentillion dollars? No. You could like buy an extra island with that, or an extra United States of America with that much money. So don't round off numbers, especially if we're in scientific notation. You might think, oh, that's a little too. That's not going to matter at all. You're literally rounding off like hundreds of billions of whatever you're counting. That's a lot of stuff. So try not to round until the very, very end, and you know you need to round. That being said, we're going to use the sapling version of this number, which is the 6.02 times 10 to the 23rd. This is a mole. 1 mole is equal to that number, 6.02 times 10 to the 23rd. And what this means is how many atoms you have. So if I have 1 mole of anything, I have that exact same number, like a dozen. If I have a dozen something, how many do I have?
12.
Yeah. If I have a dozen cars, how many do I have?
12.
If I have a dozen students,
12.
yeah. It doesn't matter what I count. I can have a dozen dollars or a dozen quarters, or I guess if I was rich, I could have a dozen houses. It's just a counting, and you can apply that number to anything. That's what a mole is. So you can see in the bags that we have around the room, everybody has a bag. Hold it up real quick. Every single bag, except for the water, because I didn't weigh the water exactly, but every single bag has 1 mole of atoms in it. So everybody that's holding a bag, your bag has that many atoms, almost precisely. Obviously, we're going to be off a little bit, but the more precise you weigh, the closer you're going to get to this number of atoms or molecules. This is a mole. Now, can I count atoms? Like, can I physically separate them apart? No.
No.
And even if I could, how long would it take you to count that many atoms?
Sometimes.
Like your entire life. You'd die before you got even halfway there. Yeah, like imagine if you were counting like an atom every second, you wouldn't even get halfway before you died. Like you don't have anywhere close to that many seconds in your entire lifetime. It's a ridiculously big number. So even if you were counting super fast, a single atom every second, or let's even say you had like 5 or 10 atoms every second, you would still die before you were able to finish counting this number. You'd be like long gone dead. So how do we count this stuff and in a meaningful way in the lab and know how many atoms we have without spending the time and the actual physical activity counting them? We do the math. We use numbers like Avogadro's number, and we do the stoichiometry in the math to figure out how many atoms we have, how many atoms we have of a chemical that's going to interact with this, and when they do interact, how many atoms are we going to have left over? Because not everything is always going to match up 1 to 1. Sometimes you're going to have a little bit left extra of one thing or a little bit left extra of another thing. We need to know how much extra. And so at first, when we're learning the math, know that this is going to be a little bit abstract. You're going to be like, why are we doing this? As we get into the harder and harder problems, you're going to be doing stuff this year that people will literally pay you money to do in a job. Like, not like I work at the grocery store money, but like I work in a chemical plant and I could be called a chemist. Yes, thank you. That kind of money. And so I've said this all year long. If you happen to be good at math, or you happen to be good at chemistry, or some other school subject that everybody hates, including you, whether you hate it or not is irrelevant. Just ask adults, like, how many of them like their jobs? Most of them are gonna be like, no, I go to work because I need the money, but I don't like my job. And so if someone's gonna pay you to do something you don't like, welcome to being an adult. If you happen to be really good at that thing and they're gonna pay you more money than some other thing you don't like, maybe that should be the thing you do. I don't know that any of y'all are gonna be chemists, but I know that some of y'all are gonna go through this really easily and be like, this was not difficult. I get it. Once I got it, I got it. The rest of you will probably struggle a little bit, but we'll get through this. If you do every single assignment, you will pass this semester. The only people I have failing this year, which is more than any other year, is people that just weren't doing the assignments. They just have zero. So do the assignments, follow along with us, and we'll get to the end of this. We're going to watch a little video on moles. And those of you that have the Ziplocs, you can pass them around or just kind of like look at them and kind of consider what's going on as we watch this video. But everybody pay attention, and then when we get done, we will start on the assignment, which if you did the assignments while we were gone on remote, you've probably already done it and you might know all the answers, but it'll be kind of a good refresher to get back into it before we get into the difficult stuff. So without further ado, here is an Avogadro video, which should help out a little bit. Avogadro. This is his number. For those of y'all at home today, hold on, I'm gonna pause this. Google search. What is it? How big is a mole? Search how big is a mole. Find this video on YouTube and watch it, because if I record this right now, YouTube will take my video down, which is not cool. So